Welcome to Edubbey Global Solution. Now, mathematics class again, we're going to be looking at another topic, which is probability. We're going to be looking at examples of probability. We are using Venn diagram to explain probabilities, and some examples are related to probability. When you are tossing the coin, you are and you are tossing the dice, and so on and so forth. So we have our interactive content here that we serve as a guide for this class. Okay, so let's start with the first interactive option, which is what? Probability is the study of chance or the likelihood of an event happening. Yes, probability is the study of chance or the likelihood of an event happening. Okay, now let's look at the next one here. A favorable outcome is refers to what event in question is actually happening. So when you have a favorable outcome, that implies that event that you are trying looking at actually happened. So we call that outcome a favorable outcome. Okay, so we said that the total number of possible outcome is refers to all the different type of outcome one can get in a particular situation. Okay, so now let's look at an example of when you toss a coin. Now we have what? We have head and we have tail. So all the possible outcome that we can get by the time we just throw a coin, then we call it what? A total numbers of what? Of possible outcome we can get in that particular situation, that is throwing of a coin. Okay, so that gives us the total number of possible outcomes. Now, if you want to calculate probability of an event, then we have it to be number of favorable events over total numbers of equal likely outcomes. We have told us that our favorable outcome is what? Is the event in question that is actually happening at that particular time. And when you are talking about total number of possible outcomes, we have different types of outcomes that can happen in a what? In a particular situation. And by the time you divide both of them, then we call it the probability of that event happening. Okay, so we want to look at the possibility of an event to occur. So if the probability that dash equals probability equals dash, then the event is what? The event is impossible. So if your probability equals 0, then that event is impossible. That is, that event cannot take place. Okay, now what happens when an event is certain? So if the probability equals dash, then that event is certain. So if your probability equals 1, then that event is certain. Okay, so now let's look at the next situation. Now what happens if an event is not occurring? We have told you that when event is not possible, then the probability is 0. When the event is certain, the probability is 1. So if the event is not likely to occur, there is going to be 1 minus the probability of the event occurring. So we have 1 minus the probability of the event occurring. Okay, now let's look at this activity. An ordinary fair dice is rolled. Calculate the probability of getting 6. Remember, we all know how a dice look like. Is it that we have 1, or we have 2, or we have 3, or we have 4, or we have 5, or we have 6? That's just what makes a die. Now let's imagine that we told this just once based on this question. Now we should calculate the probability of what? Probability of getting a 6. So now, how many times do you think we can get a 6 inside this die? It's just 1 time. So the probability of the favorable outcome is 1, okay, and the total number of that outcome, which is the total number of the die that is being rolled, is what? Is 6. So if you want to get the probability of getting 6, probability of getting 6 is now going to be what? 1 over 6, and that is the probability of getting 6 in a die that is being rolled. Now let's pick the right answer inside these boxes. Now we are to roll a dice. We have 1 towards the next one, 3. Okay, after 3, what else can we find in the die? We have 4. After 4, what else can we find in the die? I think we have 5. Okay, and after 5, what else can we find in the die? Only 5, 6. Anything after 6, we can, that doesn't make a die a die. Okay, so we are told now that the probability of getting 6 is just 1. So the total number of that outcome is going to be what? It's going to be 6, right? Now, if we want to get the probability of getting 6 is going to be what? 1 over 6. Now, what is the probability of not getting 6? As we have all said before, the probability of not getting an event not happening is 1 over that the event is happening. So it's going to be 1 minus, okay, rather 1 minus 1 over the event is happening. So 1 over 6 is probability of getting 6. So let's get the fraction done. 6 and 1, we have it to be 6, okay? So if we have that to be 6, 1 can go in 6 times, okay? 6 times 1 will give us 6 minus 6 in 6 is 1, 1 times 1 will give us 1, 6 minus 1 will give us 5. So we are 5 over 6. So the probability of not getting 6 is what? Is 5 over 6. So let's fix that into the boxes and let's check our arrangement. Okay, we are right. Now let's look at likelihood of an event. The likelihood of an event varies from one event to another. Therefore, the possibility of the event is not constant and can be found by experimenting or with calculating. Okay, so if you want to get the likelihood of an event, if you don't have any constant event, so what we just need to do, like we have done in the rolling of a die to get a 6, is that either we experiment it or we calculate it. So you can have this skill just to suggest how our probability goes. So we have impossible when it's not certain at all. There's no probability of it coming. We have 0 when it's unlikely. So it's likely to fall in between 0 and half. When it is evenly, that is, there is likely, it's likely to occur, then it falls between half and 1. When it is certain that that event will occur, like it's just like you are not fasting and there is certainty that you are taking your breakfast, then the probability is what? The probability is 1. Okay. Now we look at when we are trying to represent probability using Venn diagrams. Okay. Venn diagram is also a way of representing information when carrying out probability calculations. And remember, we've done this under set theory. We have this symbol to illustrate a universal set. We have this symbol to illustrate a set, like having set A or set B, like collection of a well-defined object. That is the definition of a set. Then we are talking about union. We have this union symbol here, and intersection. That is what is common between two sets. And union is what is in set A, and when it is set A, you are bringing the two sets together. Okay. Now let's look at this activity here. We have a card that is being arranged from 1 to 15 inside 2 given sets. The very first set is what? Is set A, and the second set here is what? Is set B. So if you look at this, if the set A, we said, is multiple of 3, okay, and set B is multiple of 5. So anything after set A, which is multiple of 3, anything after multiple of 3 must not be in set A, and anything that is not multiple of 5 must not be in set B. So for us to get set A, what we just need to do is find the multiple of 5, which is 3 times 1, 3, 3 times 2, which is 6, 3 times 3 is 9, 3 times 4 is 12, and 3 times 5 is 15. 15 is the maximum number of that card. And for set B, multiple of 5. 5 times 1 is what? 5. 5 times 2 is what? 10. 5 times 3 is what? 15. 15 is the maximum number in that set. Okay, so you see that we have the set here, set A and set B. So we have already represented the information using the Venn diagram. Okay, now did I say that a card is picked at random? Okay, so we have to calculate that the probability is from set what? Set A. What we just need to do is that numbers of the favorable outcome divided by the total number of the outcome. The total number of the outcome here is what? Is 15. Now, what are the number of the favorable outcome? How many numbers are in set A? Let's start. We have 1, 2, 3, 4, and 5. So that implies that the probability of getting the set A is what? Is what? That is 5 over 15. 5 over 15. 5 can go in 15 how many times? That's 3 times. So our final answer is going to be what? Final answer is going to be 1 over 3. Okay, so we said the number of elements in set A is what? Is 5. Okay, that is okay, we are just having a drawing here. So that is we have 5. Okay, so if that is it, then NA is 5. That is we have 1, 2, 3, 4, 5 in set A. Okay, so the probability of A is going to be what? 5 over 15. And by the time you divide that through, it's going to be 5 in 5, 1, 5 in 15, 3 times. So we have 1 over 3. Now, we want to get the probability of A intersection B. That is, What is common to set A and set B? Now let's look at this diagram. 15 is common to set A and set B. That is just one favorable outcome. So if you want to get the probability of P in A intersection B, rather, is going to be favorable outcome divided by total number of the outcome, which is 15. So that is what? That is 1 over 5. And that gives us the solution to that problem. Okay? Now, let's look at relative frequency. How do we calculate relative frequency? It's calculated by given we have the number of successful trial divided by the total numbers of trial. Now, we have an experiment here. A footballer decided to do a simple experiment by spinning the coin lots of times, and the result is shown below. So, a footballer tried to spin a coin different times, and we have the results here. So how do we calculate the relative frequency? You know what? A coin either have a head or a tail. So it's just two ways. Either you have a head by the time you spin it the very first time, or you have a tail by the time you spin it the second time. Okay, so I want to get the relative frequency. That is the number of successful trial divided by the total number of trial. So the total number of trial for the first one is 100, and the number of successful trial, which is N, is 40. So that's going to be 40 divided by 100, will give us 0.4. 90 divided by 200 will give us 0.45. 142 divided by 300 will give us 0.477. Okay. 210 divided by 400 give us 0.525. 260 divided by 500 give us 0.52, and that's how it goes. So from this table, what do you think we noticed? Okay, we noticed that the greater the number of trials, that is, the more the coin has been tossed, the better the estimated probability, or we call it frequency, relative frequency. So if you look at this, the greater the numbers of trials, then we see that the relative frequency is actually increasing. Okay, and that gives us an illustration on how to calculate relative frequency. Okay, now we have an activity here. We are going to be doing this together, and we want to get the solution out. Okay, so what do we need to do? Let's solve this question. There is a group of 250 people in a hall. Okay, a girl calculates that the probability of randomly picking someone that she known from the group is 0.032. Now, calculate the number of people in the group that the girl knows. When you are calculating probability, you said probability is what? Probability gives a number of favorable outcomes. Let's just denote it as over the total numbers of what? Of outcome. Okay, so from here, this girl, we already have the probability of the person that she knows to be what? 0.032. Okay, probability of favorable outcome, we don't know. That is the probability of those people that girl actually knows is not given. So that's what we are looking for. Let's assume that we represent it as F, since we are dealing with what? Girls. Okay, now that female, right? Now the total number of students inside that class is what? Is 250. That will give us the total numbers of the outcome. So we want to calculate F. So all you just need to do is what? We cross multiply. So we have 250 multiplied by 0.032 equals F. Now 250 multiplied by 0.032 will give us what? 8 equals F. So that implies that the girl actually knows that 8 people inside that class. Okay, that gives us a solution to that problem. So the probability is number of favorable results over the number of possible results, and 0.032 is the probability of the actual numbers of people that she knows in the class. And by the time you cross multiply, the number of people that the girls know is what? Is 8. Okay, so let's check our arrangement. Let's look at the past question that we have here. Tom has 50 model cars. Okay, he has 10 blue cars and 19 red cars. Okay, he has no yellow car. Okay, so we now say that Tom can choose a car at random. Just decide to pick any one. Then write down the probability that it is red. So let's start with the total numbers of the outcome is what? Is 50. That's the total number. Okay, how many blue? Blue, let's represent it with B. Blue is 10, and red is what? Red is 19. So what's the probability that he has a 9, he picked the red car? It's going to be numbers of red over the total numbers of car, which is what probability of red equals 19 over 50. Okay, they now say that what probability that it is not red and it is not blue. So it decides not to, it doesn't know the color that he actually picked. Tom does not know. So we have is either not red or blue. So that is going to be probability of red divided by total number of the car, and then probability of blue car divided by total number of the car. Okay, that is 10 over 50 plus 19 divided by 50. Okay, since we have a common LCM, remember when we were dealing with LCM, so we have it to be 50. Okay, so if we have it to be 50, that is going to be 10 plus 19 will give 29. So we have it to be 29 over 50. So the probability that it is not blue, probability that it is not blue. So that implies that it's going to be 1 minus probability that it is blue. What's the probability of blue? That's 19 over 50, right? So it's going to be 1, not blue, okay? Not B. It's going to be 1 minus 19 over 50, okay? If you find the LCM, it's going to be 50, that is 50 in 1, that is 50, multiplied by what? Minus what? This is 19, everything divided by 50. The LCM is 50. So 50 minus, okay, blue is 10, right? We have 10. So it's going to be 50 minus 10. So 50 minus 10 is what? 40 over 50. So that's the probability that it is not blue. Okay, now the probability that it is yellow is what? Is 0. Why? Because Tom does not have any yellow car. So the probability of yellow here is 0. Okay, now the probability that a car is damaged is 1. So how many cars are damaged? So this place is telling us that the probability that a car is damaged is 1. That is, probability that an event is going to happen is 1. So that implies that all the cars is actually damaged. So all the cars that Tom have is damaged cars. So the probability, how many cars are damaged? Number of cars that are damaged is what? 50 cars. Okay, that takes us to the end of our class. We want you to subscribe to our channel www.edubbey.com for the full interactive content of this class.